Today I've got 3 very hard mechanics questions for you. So if you're aiming for an A star, then these should hopefully give you a good challenge, and you might even still struggle with them. We'll start with question 1 as always. In question 1, we've got 2 particles creatively named A and B, which are 10 meters apart, and they are on a horizontal ground. Both balls are projected simultaneously towards each other, and at some point they're going to hit. We're also given the fact that particle A is projected with speed u, angle of elevation alpha, and B is projected with speed v, an angle of elevation 2 alpha, so twice as big. The only other information that we're given is that they intersect, so they hit mid-air after 1 second. And using that, we've got to show that this fun equality is true. Here's my diagram of the situation, which is totally inaccurate because 2 alpha is looking about the same as alpha, but it's fine. Let's consider particle A. Because it's a projectile, we're going to use suvat. We're going to use suvat in the up and down direction. So S, U, V, A, and T. The S represents the displacement. How high does it get? Well, we don't really know, but let's call it Y. When it intersects, we'll call that distance in height Y. What's the U going to be? That means what's the initial speed? It's not the same as this U. This stands for initial speed in the up and down direction. Well, we can see it's going to be the component of this U, which is U sine alpha. V, I couldn't care about, but A, I do, and it's going to be minus G. Minus because gravity is bringing us down. And then T is going to be T. In the side-to-side direction, we only need to consider S, U, and T. V is the same as U because there is no change in the sideways motion. It is constant. And similarly, A is 0 because it's constant in the sideways direction. There's no increase, there's no decrease in speed. S is going to be the distance, and that's going to look like this, which I'll call X. In fact, I'll call X1 because we're going to need X2 later on. U is going to be the speed side to side, and that's going to be the horizontal component of U, which we're going to call U cos alpha. And then T is T. Now we can do a similar thing for B. Set out our suvat, and we're going to have some very similar equations. S is still going to be Y. Because the particles meet, the heights have to be the same. You can't have 2 particles meeting if they are a different height away from each other. That's the definition of not meeting. The speed up and down is going to be very similar, but replacing U with V and replacing alpha with 2 alpha. So V sine 2 alpha. V we still don't care about. A is still minus G, T is still T. And then side to side, still only needing S, U, and T. We're going to have S as the distance travelled, which is going to be x2. We're going to have U as the horizontal component of the speed, which is V cos 2 alpha. Both of these I've made positive, even though it's going to the left. But because they're both positive, then it's all fine. Everything will work itself out. And then T, who'd have guessed it? It's T. And from here, we can use our good old friends, the suvat formulas, including S equals ut plus half at squared. So for particle A, we're going to have S equals ut plus half at squared. And then similarly for particle B, same equation, but now it's going to be V sine 2 alpha t, and then minus a half gt squared is going to stay the same. Well, this is y, and this is y. So that means that these two must be exactly the same as each other. And if these two are exactly the same as each other, then you'll notice that this disappears, and this disappears. And this needs a bracket. But we can also disappear the t's. We don't need them anymore. So this tells us that U sine alpha must be equal to V sine 2 alpha. which means that v is going to be equal to u sine alpha over sine 2 alpha. And that's going to help us get to the final answer. For side-to-side motion, we can create an equation by simply using s equals ut. It's basically rearrangement of speed equals distance over time. So that tells us that x1, s, is equal to u cos alpha t. And similarly over here, for particle b, x2 is equal to v cos 2 alpha t. But we have an equation for x1 and x2 because we are told that both particles are 10 meters apart. So surely, if x1 has travelled only 4 meters, x2 must travel 6 meters to make sure the particles collide. So this tells us that u cos alpha t is equal to, no it doesn't, plus v cos 2 alpha t, that's equal to 10. And you notice I've rearranged for v, so I'll sub it straight in. We get u cos alpha t plus u sine alpha over sine 2 alpha times by cos 2 alpha t is equal to 10. But we're told in the question not only they're 10 meters apart, but they also meet after 1 second. So this just tells us what t is equal to. So let's make t equal to 1 by making that disappear and making that disappear. We're almost there now. So we've got u cos alpha plus u sine alpha cos 2 alpha all divided by sine 2 alpha, and that's equal to 10. Let us times by sine 2 alpha because we don't like that pesky fraction. That means we're going to get u cos alpha sine 2 alpha plus u sine alpha cos 2 alpha, you might see where this is going now, is equal to 10 sine 2 alpha. So the right hand side we've already got, just the left hand side we need to sort out. But there's a u here and there's a u here, so if I just put that in a nice big bracket, like that, and then this is the double angle formula. This is u sine alpha plus 2 alpha. This is the formula in the formula book. And that's equal to 10 sine 2 alpha, which gives us our beautiful result, u sine 3 alpha is 10 sine 2 alpha. And for those that want the extra challenge on top of the extra challenge, it's a lot of pure content, but have a go at finding the smallest value of alpha for which the particles collide in the air. Good luck. Our next hard question is another projectiles question, and this time, once we've read all this, we've got to show that this result down here is true with tan alpha and tan squared alpha. What's actually going on? We've got a ball on a platform which is 1 meter above the ground, which you can see in the diagram. The ball is kicked, as you can see, with speed u, and is modelled as a projectile. We're told that the ball is 20 meters away, and some children are playing a game which they have to kick the ball and hit inside the red region. Now it does say between 1 and 3 meters high here. It should say between 1 and 4 according to the diagram. My mistake. So like the last question, because it's a projectiles question, we're going to be using Suvat equations. And this time we're going to put them together in a very special way. I'm going to call S y again to represent the height of the particle at any given time called t. The a is still minus g, and the v we still don't care about. The u is actually the same as before. It's going to be u sine alpha. Similarly, for the sideways motion, t is still t. S I'm just going to call x this time, and u is going to be u cos alpha. Now we're going to use that same Suvat as before. S equals ut plus half at squared. And we're going to use speed equals distance over time, or S equals ut, to tell us that u cos alpha t is equal to x. You might notice that there's a t here and a t here and a t here, which means that if we rearrange this for t, x over u cos alpha, we can substitute it in over here, and we'll eliminate t. So y is going to be equal to u sine alpha, lots of x over u cos alpha, minus 1/2 g that thing squared. Now we can simplify. We're going to get y equals, the u's will cancel out. The sine over cos will give us tan. And then we'll have an x minus 1/2 g x squared over u squared times 1 over cos squared. Now I'm going to write it in this form because then hopefully you'll notice the identity. 1 over cos squared is the same as sec squared. Sec squared is the same as 1 plus tan squared, which means that we can write this whole thing as y equals tan alpha x minus 1/2 gx squared over u squared in brackets 1 plus tan squared alpha. Now, the only thing that we don't have yet is x, but that's given in the diagram. We're told that the distance going across side to side is equal to 20. So this would be a general equation, but we can sub 20 in now because we know what that distance is. So 20 tan alpha minus 1/2 times by 400 g over u squared 1 plus tan squared alpha. And given that we've subbed in what x must be, what about y? Well, we know that y is either 0 because it's sitting on the same level 1 meter above the ground, or it's 3 meters higher. So that means that this whole equation for y is between 0 and 3, which, by timesing 400 by half, will give us exactly the equation given in the question. If we scroll down a bit, then now we're given the value of u squared. We're told that u squared is equal to 40 over 3 root 3 g. And we're told that the ball hits the zone. We need to show that tan alpha is between those two values. Let's sub it in. We know what u squared is, so we'll sub that into the given equation. 0 is less than 20 tan alpha minus 200g over u squared, brackets 1 plus tan alpha squared, and is less than 3. This will mean that 0 is less than 20 tan alpha minus times by 3, 600 over 40, 6 over 4, which is 15, 15 over root 3, 15 root 3 over 3, 5 root 3, the g's cancel out, 1 plus tan squared alpha is less than 3. And what we can do, we've got two equations. Essentially, we've got 0 is less than it, or the equation is less than 3. And we'll work out both individually and see what answers we get. Now for ease, I'm just going to call tan alpha t, even though it's not the same t as before. And we're going to write it like this. And I forgot to turn that into a t, like I said it would. Here, you'll probably use the calculator. I just like calculating from scratch. And we're going to get 1 over root 3 or root 3. Given that this was a quadratic, they're both positive, so that diagram is absolutely awful, but it doesn't matter too much. This is bigger than 0, so this means I've done something wrong, which I absolutely have. I've changed this sign incorrectly. That should be less than, that should be less than, that should be underneath, and therefore tan alpha must lie between these two values. But that doesn't exactly tell us what's going on over here. If 20t minus 5 root 3 minus 5 root 3t is less than 3, what happens in that situation? Well, let's bring over the 3, making sure to get the correct inequality sign. Now what we can do, we can think about b squared minus 4ac. The discriminant, we're going to get 400 minus 4 times minus 5 root 3 times by minus 5 root 3 minus 3, and I'm not going to work that out. That's going to be less than 0 because then it will have no roots, which means that this will always be true. If you can imagine that, if it's got no real root, it will never touch, so the equation will always be bigger than 0, or because it's a negative one, it will always be below, which means this quadratic will always be less than 0, as in the diagram there. Which means we can essentially ignore all this, and this must be the answer over here, which is what we wanted. And then the last one, mark. Hence find the set of values for alpha for which the ball hits the red zone. Well, hopefully you recognise these as exact trig values. This means that alpha will be between 30 and 60 degrees. Time for question 3? I think so. In question 3, it's not another projectiles, it's a slope question. We've got two particles which look suspiciously like boxes, and they're on two slopes of a triangle. We've got a coefficient on the left, which is called mu A. We've got a coefficient of friction on the right, which is called mu B. On the left, we've got alpha, where tan of alpha is equal to 5 over 12. Can't quite read that. And on the right, we've got tan of beta, where beta is 12 over 5. Particle A, back on the left, 2.6 kilograms. Particle B, 13 kilograms. Wacky answer of the acceleration is there 35 over 52 g meters per second squared. And we've got to show that this down here is true. Let's set it out. I'm probably going to start with my forces on my diagram. For A, we've got the mass times by g to get the weight, to get the force. Similarly for B, 13 is the mass, so 13g is the force. Tension is always away, T up here, T up here. The tensions are the same, even though it doesn't say, because they're attached by a light string and the pulley is smooth. That could be a modelling assumption, so remember that that's true. Where is there going to be friction? Well, both slopes have a coefficient of friction, so there's going to be friction both ways, but we have to work out where the particles are going. Well, given that 13 is heavier, I would definitely imagine acceleration in this direction. The A's are going to be the same acceleration, and that's because, again, even though it doesn't say it, that's my mistake, this string is going to be inextensible. Well, if it's going that way, then friction is going to be opposing it. So I'll call this friction A, FA, and up here I'll call this FB for friction for B, again, going backwards, opposing the motion. Now, although this question looks hard, it's really just F equals ma. So let's work out F equals ma for particle A. Going in the direction of motion is T, and going back is FA, and it's not 2.6g, but it's 2.6g at an angle of alpha, which is 2.6g sine of alpha. F equals ma, so this is going to be m, which is 2.6, times a, which is 35 over 52g. And we can do exactly the same thing for B. It's coming down, so what's helping the motion is not 13g, but it's 13g sine of beta. And then what's opposing the motion, going backwards, minus t and minus fb. And that's going to be equal to m, which is 13, and a, which is the same value as before. Well, because we know that tan alpha is equal to 5 over 12, we can draw a little triangle. This is alpha, 5 over 12. This is a 5, 12, 13 triangle. You might recognize it, you might not. It's the 3, 4, 5 triangle's lesser known cousin. Well, beta is actually going to be just up here. It's in the same triangle. This is a 90-degree triangle because beta is here 12 over 5. So 13 is still going to be part of it. From this, we can find what sine of alpha is, which is going to be 5 over 13. And I don't know if we'll need it, but cos of alpha is also found by doing adjacent over hypotenuse in the same triangle. We can then also find what tan of beta is, sine of beta, and cos of beta as well. So you've done plenty of F equals ma. Remember that when you add together these two equations, the t's will cancel out. I don't see any t's in this final answer, so we're definitely going to try and get rid of them. So let's add together these two equations. We're going to get minus fa minus 2.6g sine alpha, which is 5 over 13. And then we're going to add on 13g sine beta, which is 12 over 13. Minus t disappears with the plus t, and then minus fb. That's going to then be equal to this plus this, which is 2.6 plus 13 times by 35 over 52 G. The only thing we've not got in there yet is the mu's. Well, Fa is the frictional force at A, and that's going to be mu times by the reaction force. So we're going to have minus mu times by the reaction force at A. The reaction force A is going in this direction up here. So that's going to be the same as this here. And this here is 2.6 times by G times by cos of alpha. I'm just going to put that straight in. That's going to be 12 over 13. All these terms in the middle are the same. I probably should simplify as I go along. I'll do 12 times G here, 13 is cancelled out. And then we get to FB. Now FB is going to be very similar. It's going to be mu, this time it's mu B rather than mu A, times by the reaction force at B. Well, that's up here. That's going to be very, very similar. 13 G cos beta, which is 5 over 13. And then over here, I might turn this into 26 over 10, because then I can try and divide by 52, which is 13 times 4. We'll see where we get from there. Simplifying over here, we're going to have 2.6, which is 26 over 10, divided by 13, which is 2 over 10, 2 over 10, which is 1 over 5, times by 12, which is 12 over 5. Then we're going to minus the same thing. That's still 1 over 5, times by 5 is just 1, so just G, 12G. Then over here, 13s are going to cancel. That's a bit easier to do. That's just mu B times 5G. And then over here, we're going to get 13s cancelling. So 1 over 5 plus 1 times 35 over 4G. I see a whole host of G's, including one that I accidentally missed off. So I'll cross that off too. And then what we're going to get is minus 12 over 5 mu A minus 1 minus 12 minus 5 mu B, and that's going to be equal to 1/5 plus 1, which is 6/5 times 35 over 4. Let's see what we're going to do with this. Let's put everything over here. 12/5 mu A plus 5 mu B, and let's subtract this. This is divide this, get 7, divide this, get 21 over 2. So we're going to subtract 21 over 2. 11 minus 10.5 is going to give us a half. And then finally from here, let's times everything by 10. 10 times half is 5. 12 over 5 times 10 is 24. And 5 times 10. Hopefully no more mistakes for today. 5 times 10 is 50. Well, there you have it. 3 more questions complete. Hopefully those got you thinking, and I also hope your actual exam questions are a tiny bit easier. See you in the next one.